Hey there. Going to do a quick little lesson here on some mental math. This is from my 7th grade curriculum. These two concepts are also taught in my 6th grade curriculum, but they're done in two separate lessons. So if it seems a little fast, but I think that these concepts, first of all, part of it is in the standards for both 6th and 7th grade. That's the distributive property. And I also think it's important because it really teaches us to be efficient. And a lot of times I will do this where I'll put in little extras, maybe vocabulary. You'll see another little extra here in a second. Efficient, capable of producing desired results with little or no waste of time or materials. I'm passionate about efficiency, and I love these concepts. I did not learn about these little tricks until I was well in my career of teaching math, and they're really fun, and I think you'll enjoy it too. So the first thing we're going to look at here is called short division. And short division is different from long division in two ways. The first way that it's different is we do the subtraction mentally. It's done mentally. And these are the notes that your child would have, and they would be following along with the lesson. So we do the subtraction mentally. And the second thing that's different about short division is that you don't bring down, you bring up. And that's going to make sense in just a few seconds. So we're going to start by doing long division. We're going to use 1,236. We're going to divide it by 4. And we're going to just look at the long division so that we can see the differences and see the efficiency of it. So 4 goes into 12 3 times. We do the subtraction, and we bring down the next number. A lot of kids want to say 4 does not go into 3, and they want to bring down that 6 right away, but nope, 4 does go into 3. It just goes in 0 times. 0 times 4 is 0. Subtract. Okay, again, subtract and bring down. These are the steps that are going to be different. And then 4 goes into 36 9 times, and it goes in evenly, so we're done. Now look at it with the short division. Same problem. And we can still write it out, and I didn't leave myself much room here. So 4, and we're going to put little spaces, a little bit larger than we would. Notice there's some gaps here between the numbers. Here's the difference. 4 goes into 12 3 times. We do the subtraction part mentally. So I'm going to do this over here. You wouldn't write this out because that would not be efficient, but we want to be able to go back and look at this if we need to. And we say, okay, we're doing that subtraction mentally, and we know that it's 0. Now notice I used a different color here. Normally we would bring down the 3, right? We would bring down the 3 looking over here, but we're going to bring up that 0, and we're going to put it right there. Then we would go on to the next step. Over here on the long division, we were saying to ourselves, 4 goes into 3 0 times. Look at it here. 4 goes into 3 0 times. 0 times 4 is 0. Okay, so 3 minus 0. We're doing that subtraction in our head. And instead of bringing down the 6 like we did over here, we're going to bring up the 3, which was the result of the subtraction. 4 goes into 36 9 times. And with a little bit of practice, you can find that you can just crank out these answers really quickly. It really works best with a single-digit divisor. You would not, and I don't, try to do long division or short division with a multi-digit divisor. It's really just for when you have that single digit. Okay, so then we would follow up with an example that the kids try on their own. I would give the kids a head start. But I'm also going to point out a little something here. It says use short division to simplify the fraction and convert it to a decimal. So we see that it's 243 over 15. I love double-digit divisors, said no one ever. I hate it. I find myself going, okay, I'm writing out 15 times 3, 15 times 4, 15 times 5. You know exactly what I'm talking about, I'm sure. And so there's a way of simplifying, and we're going to take a little science break here. And this, believe it or not, this is science. This is a wheelchair ramp. And you're probably wondering where I'm going with this, but I'm going to tell you in just a sec. So if we tried to build a wheelchair ramp, just build a ramp right up these stairs here, nobody is going to be able to push their wheelchair up such a short, steep ramp. And so we lengthen the ramp and it decreases the slope of it. Totally math, totally science. Now, the person would have to roll their wheelchair a longer distance, but it's not as steep. It's a trade-off, okay? Really hard to go up the steep one, not as hard, but you still have to expend some energy to go up this more shallow one, okay? So what does that mean for the math? Well, let's take a look at this. We have 243 over 15. And I really hate two-digit divisors. And because I've practiced short division, I can do, a lot of times I can do the division completely in my head. Now, I know that 15 can be divided by 3 and it can be divided by 5. And I can tell that 243 is not going to be divisible by 5. But if I add the digits, and this is a divisibility rule, 2 plus 4 is 6, plus 3 is 9. 9 can be divided by 3, so that tells me that 243 can be divided by 3. Okay, denominator is easy. 15 divided by 3 is 5. But look at the short division, and because this one's really simple, we can even do it completely in our heads. 3 goes into 24 evenly. It goes 8 times. And so when we do the subtraction is going to be 0. 3 goes into 3 1 time. Dun, da, da, da. Now I've got a much easier division problem. And I'm going to do short division again. And I know 5 is not going to go evenly into 81 because that second digit there. So I'm going to go ahead and put a 0, decimal and 0. I'm going to bring my decimal up. 5 goes into 8 1 time. I do the subtraction in my head. 8 minus 5 is going to be 3. I bring up the 3, and I think to myself, 5 goes into 31. Okay, 5 goes into 31 6 times. 5 times 6 is 30. 30 minus 31 is 1. So again, I do the subtraction mentally, and I bring up the result of the subtraction. And then I see that 5 goes into 10 2 times. And that's our answer. We have converted 243/15 into the decimal number 16.2. So like that ramp, I could have done 243 divided by 15, but really, I just don't like those double-digit divisors. 15, I've actually learned my 15 times tables. Not quite as hard, but I use this little trick all the time so that I don't have that double-digit divisor. So might seem a little bit longer, but it's kind of like that wheelchair ramp. Takes a few extra steps, but I still find it easier to go that way than to try to, roll up that really steep slope there. All right, so now we're going on to the distributive property, and the distributive property gets introduced in 6th grade. So my 6th graders see this, and it gets expanded in the 7th grade curriculum, so I'm covering it again. To distribute means to deal out. So you can think of somebody dealing cards. You're going to play war, goldfish, go fish, or whatever. Distribute means to deal out or to spread. You could distribute seeds. The old-fashioned way where the farmer's walking around with a bag of seed and he's just scattering them. Okay, so distribute means to deal out or spread, like someone who's distributing handouts at a meeting. In math, distributing looks like this. We've got the example up here. You've got parentheses, and everybody knows that you do what's in the parentheses first, but we're not going to do that here so that we can look at the property. 7 times 6 is 42, and 7 times 5 is 35. Boy, talk about a lot of extra work. Then we would add these two together and we would get 77, which makes sense because if we'd done it the easy way, 6 plus 5 is 11, 11 times 7 is 77. Okay, totally seems pointless, right? Well, in this case, it is pointless. Okay, much easier to not use the distributive property here. But there are times when the distributive property is not only helpful, but it's necessary. You actually have to do the distributive property, and that comes when we start introducing some variables. But what we're going to look at here is the helpful uses for the distributive property, and that is mental math. And again, this was something I didn't learn until I was an adult, and it's so efficient that I get excited about it, and that is how big of a dork I am. Okay, so a couple different examples of where we can use the distributive property to do mental math. So a single digit times a multi-digit, like 8 times 24. And what it looks like, and again, this is what I would be doing in my head, but you can go back and watch these videos or go back and look at your notes, and you got to be able to see what was happening in your head or in my head. So we do it this way. So we take the double digit here, the 24, and we break it up into 20 plus 4. And again, we're doing this mentally. 8 times 20, 160. 8 times 4, 32. Put them together, 192. Okay, now go to this example. I would have students trying it. I'm giving them a head start. And if you have to write stuff out here, it's totally okay. In fact, I'm going to demonstrate, we're not going to write out the parenthesis part, but some people still might find it helpful to do, okay, 5 times 30, that's 150. This might be helpful for some people. 5 times 7 is 35. Put them together, 185. Boom. And in the beginning, this might not seem efficient, okay? It reminds me of my younger son. He waited 3 months from his first step before he actually started walking because for him, crawling was more efficient. But eventually, you get past the crawling stage, and this becomes very quick, very efficient. I especially love the distributive property when we have a mixed number. Now, I want you to look at these, the fractional parts here. On each of these examples, that numerator is a 1. We call these unit fractions. Okay? So these two examples have unit fractions, and you're probably already peeking. Yeah, down here, these are not unit fractions. We'll talk about that in just a second. So what it looks like, and again, we're only writing this out so that we can follow the process, is 6 times 3 1/3. We take that 3 and we break it 3 plus 1/3, which is the same thing as 3 1/3. And then the mental math comes in. 6 times 3 is 18. 1/3 of 6, and remember, multiplication, we use the word of. 1/3 of 6 means 6 divided by 2. I mean, divided by 3. My mouth is moving faster than my brain. 1/3 of 6 is 2. Put them together, you get 20. Isn't that cool? To me, that is just incredibly cool. So again, we have an example here, and I tell my students, okay, you try it, and we give you the head start. And I would pause. Okay, 8 times 5 is 40. 1/4 of 8 is 8 divided by 4, which is 2. It's 42. Talk about efficient. If you were doing it the long way, you'd have to turn this into that improper fraction. 5 times 4 is 20 plus 1. I'd be doing 8 over 1 times 21 over 4. Yuck. Totally not efficient, whereas this is. The last two ones here is single digit times a mixed number, but again, it's not a unit fraction this time. So what does it look like? Well, it looks like this. 9 times 4 plus 1/3 plus 1/3. 9 times 4 is 36. 3 into 9, 1/3 of 9 is 3. And same thing. So I've got 36 plus 6 is 42. Total coincidence that it's the same answer as the previous example. So isn't this great? I'm such a dork, but I just love this. Okay, so you try it. You try it. Giving you the head start. 6 times 7 is 42. I guess I like 42 today. And then 1/3 of 6 is 2. And 1/3 of 6 is 2. 42, 4, 6. The answer is 46. And I hope you found this helpful. I just think it is so much fun to learn these tricks that make us really efficient in math. Mathwithmrsfish.com.